Welcome. In this session, we will examine two critical aspects of Azure Compute and networking. First, we will look at how to ensure high availability for your virtual machines using availability sets. Then, we will shift focus to Azure Virtual Desktop, a desktop and app virtualization service that runs on the cloud. Let's begin. Let's start with the concept of the availability set. When you deploy a virtual machine in Azure, you want to ensure it stays online, even if the underlying infrastructure has a hiccup. An availability set is a logical grouping that you define within Azure to ensure redundancy. It is listed as a core component of a virtual machine configuration, alongside disks and networks. When you create a VM, you select the availability options, and selecting an availability set tells Azure to treat a group of VMs as a single resilient unit. This is essential for maintaining uptime without needing to manage the physical hardware yourself. This class diagram visualizes the relationship between a virtual machine and an availability set. As you can see, the virtual machine includes several components like disks and networking. The availability set is attached to the VM configuration. It contains internal logic for fault domains and update domains, which we will explore next. This relationship ensures that the VM is not just a standalone entity, but part of a broader, resilient strategy. To understand how availability sets protect you, we must look at fault domains and update domains. When you place VMs in an availability set, Azure distributes them across multiple isolated hardware nodes. A fault domain is essentially a rack of servers with shared power and networking. If the rack fails, only the VMs in that specific fault domain are affected. Update domains, on the other hand, separate VMs for planned maintenance. Azure will never reboot VMs in different update domains at the same time. This ensures that at least one instance of your application is always running, protecting you against both physical failures and software patching. This diagram illustrates the physical distribution within an availability set. We have three columns representing physical racks, or fault domains 0, 1, and 2. Inside each rack, we have a virtual machine. Notice that each VM is also assigned a different update domain, AD 0, 1, and 2. If rack 1 loses power, only VM A goes down. VM B and VM C continue running. This visualizes how the availability set physically isolates your resources to maximize uptime. Now we transition to Azure Virtual Desktop, or AVD. AVD is a comprehensive desktop and app virtualization service running in the cloud. Historically, Microsoft introduced Azure Virtual Machines first, followed by Platform as a Service, PaaS, solutions like Azure App Service, and eventually Azure Virtual Desktop. Because it is a PaaS offering, Microsoft manages the complex infrastructure like the web access, gateway, and diagnostics services, allowing you to focus purely on managing your desktop images and users. This shift significantly reduces the management overhead compared to traditional on-premises virtual desktop infrastructure. This flowchart shows the evolution and responsibility split in AVD. We move from traditional VDI to Azure Virtual Desktop. The key split happens at the Managed by decision. Microsoft takes care of the control plane, highlighted in blue, which includes the gateway and broker. You, the customer, manage the session hosts and images, highlighted in yellow. This visualizes the PaaS nature of the service, showing exactly which burdens are removed from your IT team. The architecture of AVD revolves around host pools and workspaces. A host pool is a collection of Azure virtual machines that register to AVD as session hosts. These session hosts are the actual VMs that users log into. You can configure them as personal pools, where a user gets their own dedicated VM, or pooled pools, where multiple users share the VMs. To make these resources accessible, we use workspaces. A workspace groups applications and desktops together, presenting a unified feed to the end user. You must register your application groups to a workspace for users to see them. This entity relationship diagram defines the hierarchy of AVD resources. On the left, the workspace contains one or more application groups. These application groups connect to a host pool. The host pool aggregates multiple session hosts. As shown in the attributes, these session hosts can be configured as personal or pooled. This structure allows you to organize resources logically for different user departments while managing the underlying compute efficiently. Networking in AVD is designed for security and performance. A key feature is reverse connectivity. The session hosts establish an outbound connection to the AVD management plane, meaning you do not need to open inbound ports like 3389 on your firewall. Identity management is handled through Microsoft Entra ID and Active Directory domain services. For performance, AVD supports RDP shortpath, which improves reliability and latency by creating a direct UDP flow between the user and the session host. Proper DNS configuration is critical to ensuring these components can communicate effectively. This sequence diagram details the secure connection process. The user first authenticates with the identity provider. They then request a connection from the AVD gateway. Crucially, the session host initiates an outbound reverse connect to the gateway. The gateway then bridges the session to the user. The note at the bottom emphasizes the security benefit. No inbound ports opened on the session host, visualizing how AVD maintains a secure perimeter. For enterprise deployments, AVD should be deployed within an Azure landing zone. This ensures that all your networking, identity, and governance policies are applied consistently across your environment. To manage costs, AVD uses scaling plans. These plans define schedules to start VMs when users log on and stop them during off hours. Additionally, for large-scale deployments, you should use the Azure Compute Gallery to manage and replicate your VM images, VM image definitions, across different regions, ensuring consistency for all your host pools. This state diagram visualizes the scaling lifecycle. During peak hours, if there is high demand, the system transitions to scale out and provisions active hosts. When demand drops, it transitions to scale in, deallocating VMs to save money during off hours. The cycle repeats based on the schedule. This demonstrates how AVD automates capacity management to balance user experience with cost efficiency. To summarize, we have covered two distinct but related compute topics. Availability sets provide the foundational resiliency for your virtual machines by distributing them across fault and update domains. Azure Virtual Desktop builds upon this compute power, offering a managed PaaS solution for VDI. By leveraging host pools for compute management and workspaces for user access, AVD provides a secure, scalable, and remote accessible environment without the heavy lifting of traditional infrastructure. Our final mind map brings it all together. The central node, Azure Compute, branches into availability sets and Azure Virtual Desktop. Under availability sets, we recall fault domains and update domains for resiliency. Under AVD, we recall it is a PaaS service composed of host pools and workspaces, utilizing features like RDP shortpath. This provides a complete mental model of the reliability and virtualization services we discussed.